Welcome to today's Explainer. We're jumping right in because today we are taking a massive leap in our web development journey. Seriously, it's a real game changer. We're finally moving away from building static web pages. You can kind of think of static pages like a beautifully painted but completely empty model home. Looks great, but nobody actually lives there. Instead, we're going to learn how to wire that house up, give it some plumbing, and turn it into a fully functional, living, breathing, dynamic web application. To pull that off, we'll hit our core learning outcomes for week 4. Database design principles, managing MySQL tables, doing basic CRUD operations, hooking things up with PHP, and ultimately building your very own dynamic web app. Let's get to it.
But first, I want you to ask yourself, how exactly does a website remember who you are? I mean, when you log into your favorite social media site, how on earth does it instantly know your password, your friends list, or all your past posts? Well, the answer is databases. Databases are literally the backbone of modern dynamic websites. They give us a structured, super efficient way to store and manage user data. Honestly, without them, the web would just be a static collection of digital brochures. No way, right? We absolutely need databases.
So, to build our dynamic web app today, here's our roadmap. First, the blueprint, covering database design. Second, the foundation, looking at MySQL and CRUD. Third, the wiring, which is our PHP connections. And finally, the finished house, where we build those dynamic apps.
All right, step 1, the blueprint. Let's talk about database design principles. Before we even write a single line of code, creating a logical blueprint is absolutely crucial. We have to define our entities, things like users or products, and their attributes, like a name or a price. Now, the absolute most important part of this blueprint phase is something called normalization. Simply put, this means organizing our data to reduce redundancy and improve integrity. Basically, we want to make sure we aren't storing the exact same piece of information in 5 different places. Doing this keeps the whole database incredibly efficient and totally accurate.
To put that into perspective, take a look at how we'd structure data between a users table and a posts table. Notice the keys here. In the users table, every single user gets a unique identifier, which we call a primary key, usually just an ID. Meanwhile, the posts table has its own ID, but it also contains a user_ID, which acts as a foreign key. By dropping the user's ID into the posts table, boom, we create a direct relationship. The database now knows exactly which user wrote which post, all without having to duplicate the user's name and email on every single post they write. Pretty smart, right?
Okay, moving right along to section 2, the foundation. Let's get into MySQL basics and CRUD operations. In the database world, there are 4 fundamental actions you can take, and they're grouped into a fantastic acronym, CRUD. That stands for create, read, update, and delete. These 4 lifecycle steps represent virtually every basic action a database can perform. Think about it. When you register for a new account, you create. When you scroll through your profile, you read. When you change your password, you update. And when you finally close your account, you delete. It's the whole shebang. So the crucial part here is knowing how to actually tell your database to execute these 4 steps. We do this using SQL, or Structured Query Language. To create, we use the insert into command. You specify the table, the columns, and the exact values, like say, John Doe. To read, you ask the database to select specific columns, maybe name and email, from the user's table. To update, you use the update command to set a new value. Say you want to change a name to Jane, but, and this is super important, notice how we use a where clause here to specify exactly which user ID to change. Finally, to delete, we use delete from, with that exact same where clause. Because trust me, you definitely don't want to accidentally delete the entire table. Actually, scratch that. Doing that is a complete nightmare. Always remember your where clause.
Let's jump into section 3, the wiring. Time for PHP and MySQL integration.
Now, when we're using PHP to actually talk to MySQL, our electricity, if you will, developers have 2 distinct ways to make that connection. The first is MySQI, or MySQL Improved. This uses a really straightforward procedural function called MySQLi Connect to get you hooked up. But alternatively, we have PDO, which stands for PHP Data Objects. PDO takes an object-oriented approach. It uses new PDO to connect, and it cleverly wraps that connection attempt in what's called a try-catch block. This is just a really neat way to handle any exceptions if the connection suddenly fails. What's really fascinating here is the specific attribute configuration for PDO. Look, both MySQL and PDO will absolutely get the job done, but PDO allows you to set specific attributes, like the error mode exception. So what does this actually do? Well, it forces PHP to throw a clear, catchable exception whenever a database error pops up. It makes handling connection failures so much more secure, incredibly predictable, and just way easier for developers to troubleshoot.
All right, we've made it to section 4, the finished house. Let's look at a dynamic form example.
To actually build a dynamic web app that interacts with your database, you typically need 3 main pieces to handle the journey of a single piece of user data. Think of it like a relay race. First up, the HTML form. Let's just call it index.php. This is what the user actually sees. They type in their name and email, hit submit, and send that data using the post method. Second, we have the processor, or insert.php. This behind-the-scenes file connects to the database, grabs that post data, and executes an insert query to safely save it. Finally, it redirects the user to the third piece, the display page. Display.php uses a select query to retrieve those newly updated records and actually show them on the screen.
And to get those records printing onto the screen, we use a loop with a function called MySQL fetch_aso. It looks a little intimidating at first glance, but basically this function takes the result of your select query and fetches just one row of data at a time as an associative array. The while loop just keeps running, pulling out the name column and echoing it to the screen over and over until it completely runs out of rows. It's really just a beautifully simple way to display dynamic lists.
So what does all of this mean for you? Why does it matter? Well, by mastering these exact concepts, you can now build incredibly practical, real-world applications. You literally have the tools to build functional user registration systems with basic login authentication. You can develop your own simple blog that allows users to create, read, update, and delete their posts. And as you get more advanced, you can ensure these systems are rock solid by applying security practices like input validation and PDO prepared statements. That's going to protect your databases from malicious attacks. It's incredibly powerful stuff.
Which brings us to our final provocative challenge for this explainer. Based on the assignments for this lesson, are you ready to build your very own student record system using PHP and MySQL? You now know exactly how to design the blueprint, execute those core CRUD operations, and wire the whole thing together with dynamic forms to add, update, and delete records. The tools are entirely in your hands right now, so what are you waiting for? Open up that code editor and give it a try. Thanks for joining me on this explainer, and happy coding.